Now we calculate and think a little bit about the meaning of the curl of the function f of xy equals yi plus xj, very similar to the function that we had previously, but we've switched the y and the x. When we do that, we get a function which, graphed around this circle, has the behavior that you see here. Sometimes the f function is directed outward from the circle, sometimes inward, then outward again, then inward again around the 4 quadrants. And also sometimes, as here and here, the function has a component in the direction of counterclockwise motion around the circle, and in some cases, as here and here, if we're moving in the counterclockwise direction, the function has a component that's in the direction opposite that motion. So if we were to sum up all the components around the circle parallel to the motion around the circle, we might well expect to end up with a fairly small result, and possibly 0, and that's exactly what happens when we calculate the curl. Calculation is straightforward. We set up our determinant like so, and we observe that the partial with respect to x of x is 1, the partial with respect to y is 1, so that our k component is going to be k times the minor that we get here. Partial with respect to x is 1, partial with respect to x of x, I think I said that right, is 1, partial with respect to y of y is 1, so we get 1 minus 1, and that's going to be our k component. Okay, now our I and j components are both 0, and that's easy to see. The partial with respect to z of x is 0, and we've got a 0 here, obviously. And if we calculate the j component, we're going to have the partial with respect to z of y, partial with respect to x of 0, giving us 0. So the k component is the only one that comes out with any possibility of being non-zero, but since it's 1 minus 1, we do get 0. Now, if we change this function slightly, and we make this the curl of negative I plus xj, you can verify that we're going to get 2k. The effect of that is simply going to be to change this y to a negative. The only effect that has on these results is that when we subtract the partial with respect to y of negative y, we're subtracting negative 1, which gives us a positive 1. So we're going to have 1 plus 1, which gives us 2. So the curl is 2k. Geometrically, if we change the y to negative y being the I component, we're going to be reversing the I component. If we reverse the I component of this vector, well, that moves it over this way. The j component is still positive, but the I component, having been to the right, is now to the left. So that effectively reflects each of these vectors between right and left. This vector is to the right, it'll go to the left. It's up and to the right, so it'll be up and to the left because the up-down isn't affected. This vector is to the right and down, it'll be to the left and down, and so on around the circle. And you can see this vector, when it's reflected, comes out in something like this direction. This vector, when it's reflected in the I direction, comes out in this direction. And now these vectors all have components in the direction of motion around the circle, which is consistent with the idea that curl is a measure of circulation. There's no net circulation around the origin here. There is net circulation around the origin here, and the curl comes out non-zero in this case.